Most people think bees sting their enemies, but when a giant hornet arrives at the hive entrance, the Japanese honeybee does something far stranger. She does not simply attack. She helps build a living ball around the hornet's body. The bees raise the temperature. They seal her inside a chamber made from hundreds of breathing insects. The famous part is heat. The part most people miss is the air. And the giant hornet does not know she is walking into it. To her, the hive entrance is not a trap. It is valuable. Inside are thousands of honeybees, brood, larvae, protein, a living storehouse that can feed the young back in her own nest. She is a scout, and her job is simple: find the hive, mark it, leave, and bring the others. If she succeeds, the real attack begins later. A group of giant hornets can tear through a honeybee colony with terrifying speed. They do not need to steal honey. They do not need to kill cleanly. They need to break through the workers, reach the nursery, and carry the brood home as food. So the scout lands. She walks across the hive entrance. Her antennae move. Her legs touch the surface. She is looking for the right place to mark. If she can leave a chemical signal and escape, the hive may be doomed before the bees fully understand what is coming. But the Japanese honeybees at the entrance have an answer that does not look like ordinary defense. They do not rush her one by one. They let the trap close. Hundreds of bees surge over her body. Her legs disappear first, then her wings, then her head. In seconds, the largest hornet on Earth is buried under a living ball of honeybees. Inside that ball, the temperature climbs. But something else is happening at the same time. The air is changing. Hundreds of bees are packed together, vibrating, breathing, holding tight. The hornet is breathing too, but she is trapped in the center where fresh air is limited. Oxygen drops. Carbon dioxide rises. The hornet is caught inside a hot, suffocating chamber made entirely from the bodies of her prey. She is not stabbed to death. She is sealed inside a climate. If that changes how you picture honeybees, stay with me. Because the strangest part is not that Japanese honeybees can kill a giant hornet. It is that European honeybees, the kind most people know from gardens and managed hives, often cannot. Most people who see this behavior for the first time assume the bees are stinging. That would be the obvious answer. Bees have stingers. Hornets attack bees. So the story seems simple. Hundreds of bees sting the predator until it dies. But the giant hornet is not built like an ordinary insect. Her armor is thick. Her plates are hard. Her body is designed to take punishment. A honeybee sting can penetrate soft places, but the useful targets are small: the joints, the gaps, the vulnerable tissue between the armor. In a chaotic fight, most stings do not land where they need to, and for a honeybee, stinging is not cheap. It can cost her life. Against one hornet, maybe that trade could make sense. Against a marked hive and returning hornets, it does not. The scout is not just a predator. She is a message waiting to be sent. If she escapes after marking the hive, more hornets can follow her signal back. That is the real danger. The first hornet is not the battle. She is the beginning of one. So the Japanese honeybee colony has to stop the message before it leaves. This is why the ball matters. The bees are not trying to win a fair fight outside the entrance. They are turning the entrance into a trap. The scout comes close because the hive is valuable. She steps into range because she needs to mark the target. Then the defenders close around her and create a space where her advantages stop mattering. Her jaws cannot cut the air. Her armor cannot block heat. Her size does not help when the room itself turns against her. From the hornet's point of view, everything changes at once. A moment ago, she was standing on the surface of the hive. Now there is no clear direction, no open air, no free wing movement, no clean path out. Bodies press against her from every side. The temperature rises. The air thickens. She is strong, But strength is the wrong tool for this room. This is where I want to ask you something, because almost everyone imagines the wrong weapon first. When you first heard about honeybees killing giant hornets, did you think they were stinging them, cooking them, or suffocating them? Write it in the comments. I read every one, and this question matters because the real answer is stranger than the version most people remember. The ball is often called a heat ball, and that name is not wrong. The heat is real. The bees vibrate their flight muscles without flying. Their bodies generate warmth. Hacked together, the temperature rises enough to push the hornet past her limit. The famous number is 47 degrees Celsius. That is the temperature inside the ball. The hornet begins to fail around 46. The bees themselves are near their own danger zone. There is only a narrow margin between killing the predator and killing the defenders. But calling it only a heat ball makes the behavior feel too simple. The bees are also changing the atmosphere inside the ball. That is the missing layer. The trapped hornet is not sitting in normal air. She is inside a dense pocket of heat, pressure, reduced oxygen, and rising carbon dioxide. The heat weakens her. The air makes recovery impossible. Together, they push her body past the point where strength, armor, and jaws still matter. The bees are also under stress. They are not safe inside their own weapon. They are tolerating dangerous conditions longer than the hornet can. That is the key. The trap does not have to be harmless to the bees. It only has to be more lethal to the hornet. Nature uses this kind of solution often. A fever can hurt the body, but it hurts the invader more. Venom is dangerous, but the animal carrying it survives the dose. The bee ball follows the same logic. It creates a harmful environment that the defenders can endure just long enough for the attacker to fail. The hornet dies first. That narrow difference is the whole trap. No single bee can make it happen. One bee cannot heat the hornet enough. One bee cannot change the air enough. One bee cannot hold the predator still. One bee cannot stop the scout from forcing her way out. But hundreds of bees from the same bee colony can become something one bee is not. They become the room. This is swarm intelligence in its most literal form. Not a metaphor, not a motivational phrase, a physical mechanism. No individual bee understands the whole trap, but the bee colony still builds it without a single bee knowing the whole plan. If people mean anything real by beehive mind, it is this. And this is not a normal bee attack. A bee attack suggests a swarm rushing an enemy with stings. What happens here is stranger. The bees do not just attack the hornet. They change the world around her until her own body cannot survive inside it. The same kind of colony that can send workers to flowers through a waggle dance can also produce this. One behavior sends bees toward food. This one turns bees into a trap. Each worker responds to local cues. The hornet is present. Other bees are rushing. Alarm signals are active. The body of the predator is there to grip. The pressure of the cluster increases. Muscle vibration begins. The conditions change because enough bodies are doing the same thing at once. There is no blueprint inside the mind of a bee. The blueprint is in the behavior. The hornet scout is caught inside that contradiction. She is fighting small animals, but she is losing to a system. Her body was built for direct violence. Strong jaws, heavy armor, fast movement, chemical marking. She can kill individual bees. She can terrify an undefended entrance. She can turn a weak hive into a slaughter. But inside the ball, she is not fighting individuals anymore. She is fighting the physical state those individuals create together. That is why Japanese honeybees can survive a predator that would otherwise be catastrophic. They do not need to become stronger than the hornet. They need to make the hornet enter a situation where her strength becomes irrelevant. Now compare that to European honeybees. This is the uncomfortable part of the story, and it needs a slower look. European honeybees are the bees most people know. They are the bees in many managed hives. They are the bees that pollinate crops, visit gardens, and produce much of the honey people recognize. They are not weak animals. They navigate for miles. They communicate flower locations. They build comb with astonishing precision. They regulate the temperature of the hive. They turn nectar into honey through a chain of work that can involve many bees. But they did not evolve for millions of years alongside the same giant hornet pressure in the same way Japanese honeybees did. That difference matters. When European honeybees face giant hornets, their inherited answers are often wrong for the problem in front of them. They may rush, they may sting, they may try to defend the entrance with ordinary tactics. But ordinary tactics are exactly what the hornet is built to survive. Her armor reduces the effect of stings. Her jaws can cut through individual workers. And if the scout completes her marking and returns, the colony may face a coordinated raid it is not prepared to stop. This is not because European honeybees are stupid. It is because evolution is local. Evolution does not prepare every animal for every threat. It prepares populations for the problems that shaped them. The Japanese honeybee carries an answer because her ancestors were tested by giant hornets again and again. Colonies without a good enough response were destroyed or left fewer descendants. Colonies with a better response survived. Over time, the behavior became sharper. The European honeybee's history was different, so her instinct can betray her. That is one of the hardest things to accept about nature. Being good at survival in one world does not make you ready for another. A behavior can be brilliant against one enemy and useless against a different one. The same honeybee that can solve routes through flowers, dance directions to her sisters, and keep a colony alive through winter may still fail against a predator her lineage did not have time to answer. The Japanese honeybee does not win because she is generally better. She wins because she has the right answer to this exact question. That is what the giant hornet exposes, not intelligence versus stupidity, not courage versus weakness, history versus a new problem. And the new problem can be devastating. When giant hornets attack a colony that cannot stop the scout, the raid can move quickly. Workers are killed at the entrance, the defense breaks, the hornets enter and take the brood. The honeybee colony loses not only adult workers, but the next generation. The nursery becomes the target. This is why stopping the scout is everything. The first hornet is not just one predator. She is a doorway to the rest of the attack. If she dies inside the bee ball, the chain breaks. If she escapes, the chain continues. The whole colony's future may depend on whether hundreds of workers can trap one scout before she completes one message. That is the kind of pressure that builds extreme behavior, not drama, arithmetic. If the scout dies, the hive may continue. If the scout marks and returns, the hive may not. Inside that pressure, the bee ball makes sense. It is dangerous. It costs energy. It may injure or kill some defenders. But compared with allowing a giant hornet scout to summon others, the risk is acceptable. A few hundred bees can spend themselves to protect tens of thousands and the brood beneath them. What it creates is one of the strangest traps in the insect world. A predator lured by the smell and value of a hive, pulled toward an entrance, surrounded by prey animals, and killed not by teeth or venom, but by the environment those prey animals create together. Heat, air, pressure, time. A living chamber with no door. There is something almost disturbing about how elegant it is. The hornet's greatest advantages are all external: armor, jaws, speed, size. The bees attack her internally, through the conditions her body needs to function. They do not break her armor. They make the armor irrelevant. They do not overpower her jaws. They make the jaws useless. They do not match her strength. They remove the environment in which that strength matters. That is a deeper kind of defense, and it is built from small rules. Move toward the hornet. Grip. Cluster. Vibrate. Stay. No single rule looks intelligent enough. Together they become lethal. Right now, while you are watching this, somewhere a bee is doing something much quieter. She may be standing on lavender in a garden. She may be flying home with nectar. She may be following a dance. She may be cleaning a brood cell in the dark. Nothing about her looks like a weapon, but she belongs to the same kind of organism. A honeybee is never only herself. She is part of a colony that can become more than the sum of its bodies when the right pressure appears. A garden bee and a defensive bee are not opposites. They are two roles inside the same survival system. One gathers sugar, one heats a hornet. One seems gentle, one becomes part of a trap. Both exist because the colony has to keep going. That is why the giant hornet story should not make bees look like tiny soldiers. It should make them look stranger than that. Soldiers follow a plan. These bees do not. Soldiers receive commands. These bees are responding to cues. Soldiers may understand the battle. These bees almost certainly do not. And still, the result is more coordinated than many armies. The hornet scout enters as an individual with a mission. She dies inside a collective behavior with no commander. That is the real contrast. A single, powerful predator against a colony that does not need any one member to be powerful. A hornet that knows where she wants to go against bees that do not need to know the whole plan. A direct killer against a distributed trap. The individual is terrifying. The collective is worse. When the ball finally breaks, there is no victory scene in the human sense. The surviving bees do not celebrate. They do not understand the historical meaning of what just happened. They do not know they have reenacted a behavior shaped across generations by predator pressure. They do not know the scout was a chemical message that never got delivered. They simply return to work. That may be the most honest ending nature gives. Not triumph, continuation. The entrance still stands. The brood is still inside. The queen still lays. Workers still leave for flowers. The colony absorbed the danger, paid the cost, and kept moving. And somewhere beyond the hive, a bee lands on a flower as if the world is gentle. That is the part I keep thinking about. The same family of insects that gives us the soft image of a honeybee on a blossom also contains this answer. Hundreds of bodies closing over a predator and turning breath itself into a weapon. The same creature we associate with sweetness belongs to a colony that can build a suffocating furnace around the largest hornet on Earth. Not because bees are cruel, because survival is precise. A 1-degree margin. A scout stopped before she can return. A colony behaving as if it understands something no individual inside it could explain. That is evolution's deadliest trap. Not a pit, not a web, not a jaw snapping shut. A living room of bees. And the next time you see a honeybee in your garden, small and busy and easy to overlook, it is worth remembering what small can become when it is multiplied by a colony. Alone, she is fragile. Together, her sisters can change the world around a predator until the predator cannot survive it. That is the hidden life under the ordinary one. The part we miss when we only see the flower. The part that makes a hive more than a crowd. If this changed how you see the bee colony behind the flowers, or the giant hornet that hunts it, subscribe to the channel. There is much more happening in the ordinary garden than the surface ever admits.